Okay, good morning. We are looking at two variable inequalities. So we are starting section 8 today. So what I want you to do is complete that front page of the note guides. So you're going to do 1 through 6, as well as the activity at the bottom where it comes to graphing. So I'm going to give you guys about 8 to 9 minutes to do the warm-up at the top and the graphing down at the bottom. So the first three are inequalities. If they're equal to with the inequality, then we have a closed circle. If it was a less than, then we shaded left. If it was greater than, then we shaded right. The absolute values, the first two are simply points because they're equals. And number 6, they go in opposite directions because it is greater than, which is great or. So it's closed circles and going in opposite directions. Okay, then here we have the graph of the line y equals 2x plus 3. So what we've done is plot each point listed. I color-coded the points, so if they were below, it got a B. If they were on, it got an O. And if they were above, I put an A. The points above the line are going to be included in the inequality, which is a lead-in to what we are looking at today. So points above a line for an inequality that is greater than will make them true. So you could pick any of the points listed as A or pick any of the points from above the line, and if you plug them into the inequality equation y greater than 2x plus 3, they would be true. All right, so what we want to do is talk about some vocab. The m is still slope, the b is the y-intercept. If I make the inequality y equals x, the m value is 1, the b value is 0. And basically what we're going to do is talk about how an inequality can change the look of the graph. So how can an inequality change the look of a graph? Well, it can change if the graph is solid or dashed, it can change if the graph is shaded above or below, and it can change the graph from including points to not including points. So in example 1, the graph is shaded below because it's going to be y values less than. The graph will have a dotted line or a dashed line because it is not equal to. In example 2, the line is now solid, but the shading will remain the same. So the shading is going to stay below the graph because it's y less than or equal to. So therefore the shading stays, but the line becomes solid because the solutions come on the solid line and from the shaded region. So in number 3, now our difference is that y is greater than x. Well, if y is greater than x, then those are the points above the line because it's all those points above it that are going to be greater than it. Now again, y is greater than but not equal to, so my line has to become dashed. And again, the idea here is that the solutions are not included on the line since the line is dashed. So it's just the y values greater than those points on the line. And then last, we have y greater than or equal to. So once again, shading remains the same, but now the line is solid because the solutions would come from the line y equals x, as well as the shading above the line. So all in all, we can see 4 different types of examples with that same inequality. So it leads to a solution. A solution to an inequality is simply a point, xy, on the graph that makes the inequality true. So again, if it's shaded above, points come from above. Any of the points on the line, if the line is solid, will make the inequality true. So our solutions depend upon our inequality. If we graph y greater than or equal to 2x plus 4, then my solutions are going to be any of the points on the line or above. So in order to graph the line, we are going to plot our points at 4 for the y-intercept. And then I'm going to graph the slope up 2 over 1, up 2 over 1. And then I could also go in reverse and go down to left 1. The line is greater than or equal to, therefore it is solid through all of those points. So it says, what is a point that is a solution to the inequality? You could pick any point on the line. You could pick any point above the line. So again, any point above that line would be a solution. So we're going to shade all the space above that line. Number 1 has an infinite number of answers. You could put anything you want. Any of these black dots are going to be solutions to that inequality. Now, what is a point that is a solution to the inequality that is not a solution to y greater than 2x plus 4? That would be any point on the line. So it would be any point on the line. Now, the last part, sorry about that. The last part says, where does this point fall on the graph? The points are going to fall again at any point on the line. So number 2, lots and lots of answers. You could pick the y-intercept, 0, 4. You could pick the point 1, 6. You could pick the point 2, 8. Any point that is on the line. Now, if the symbol is greater than or less than, the line is dashed or dotted. If the symbol is greater than or equal to or less than or equal to, the line is solid. If it is greater than or equal to, you shade above. And if it's less than or equal to, you shade below. So if you're going to graph y greater than 2x plus 3, on which side would the shading be? Well, since it's greater, it could be above the line. If you're talking about sides, it would be to the left of the graph. So you could say left or above. Is the line going to be solid or dotted? It's going to be dotted, or you could also say dashed because it's y greater than. Let's graph that. So what we're going to do is start with our y-intercept, so 0, 3. And then you're going to follow your slope, so up 2 over 1. Up 2 over 1. Up 2 over 1, down 2, left 1, down 2, left 1. Once you have a good bit of points, you're going to connect them with your dashed line. And then it says check your work by shading to the left or above. So we're going to shade to the left of that line. And above as well at the same time. So to the left and above. And then it says name 3 points that would be solutions. Again, there are an infinite number of points that could be solutions. So just make sure it comes from the pink region. So you could do -4, 0. You could do -2, -4, -2, 4 rather. You could do 0, 8. So again, you could pick a bunch of different points and they would make that true as long as they are in the pink shaded region. We could take a point we picked and plug it in. This is called a test point. So you could take a point you pick and plug it in. This is known as a test point. So let's also graph the following inequality. So what we're going to do is find our x and y intercepts. So the y-intercept occurs when x is 0. So we're going to plug 0 in for x and solve for y. Upon doing so, that will give me the y-intercept, and that will give me a starting point for my graph. Next, we can plug in 0 for x, or 0 for y rather, and solve for x. That'll give me my x-intercept, which will also give me another starting point to graph. So we're going to plot our x and y intercept, connect those 2 points. We're using a dashed line because it is a less than. And now, since it's in standard form, you have to actually be careful. Just because it's a less than doesn't mean you shade below. So what I did is I picked the point 0, 0, plugged it in, and saw that 0 plus 0 was less than 8. Since that was true, I knew I could shade below. Your other option would be to rearrange the equation and put it in slope-intercept form. So subtract 2x, divide it by 4, so you get negative 1/2 x. And then take 8 divided by 4, so you get 2. Once again, shows my y-intercept, shows my down 1/2, and it also shows that y is less than, so you shade below. Lucky for us, example number 2 is in slope-intercept form, so we don't have to worry about that. We're going to plot our y-intercept and then apply our slope. So it goes through 0, 5, down 2 over 1, down 2 over 1, down 2 over 1. My line is solid because it's greater than or equal to. And then again, the y values are greater than. So that tells me we shade above that line. So we're going to shade above the graph. And that is how you graph linear inequalities. Please complete the next page in your packet for homework.